Hey everybody, Michael Snyder, Pacific Northwest and California Weather Watch. Today's June 25th. We're going to take a look at ENSO conditions across the Pacific Ocean here, otherwise known as La Nina, neutral, or El Nino conditions. And we're going to see where we are now, where we're headed, and what we can start to expect here as we go through the fall and the winter months upcoming here. So right now we are in the neutral phase right now. This is Nino 3.4. This is where we measure these conditions here between 170 west and 120 west, 5 degrees north and south of the equator. You can see the Hawaiian Islands here. There is North America, there is Australia, there would be Japan, and South America to the bottom right over here. You can also see the other regions, Nino 1 plus 2, Nino 3, and Nino 4 in the blue box here. So let's start to dive into some of this here. And we are in La Nina watch currently right now as we speak. Right now we are in neutral conditions. However, La Nina likely coming up here as we go through the fall and the winter months. We're going to dive into that in some detail coming up. But El Nino is officially gone here. We are below the 0.5 cutoff there. So we are in neutral conditions here. El Nino is now officially over. If we take a look at Nino 4 is at 0.5, Nino 3.4, as I said, is at 0.3. Nino 1 plus 2 is the interesting one there. You can see where the upwelling is occurring right on the coast of South America here, and that water eventually snakes out across the Pacific Ocean here, starts to infiltrate into Nino 3.4. And of course, this has global circulation implications, and we're going to dive into that in a bit here as well. So as far as the diagnostic discussion, La Nina is favored to develop during July, August, September 2024 and persist all the way on in through the winter here, probably on in through the early portion of spring at least. La Nina is considered the dominant extratropical influence on the forecast. So with La Nina being the impacts that are key driver of the forecast here during the winter and early spring, that is why the probabilities about over the Pacific Northwest are below average here. And we're going to take a look at those here coming up in a moment. And that was issued June 20th, a few days ago now. So these are the ENSO probabilities. You can see El Nino gone, basically zero here. I mean, you're talking about 1 or 2% chance, and you can see neutral conditions that we're going to be in here through May and July, and then probably on in through July here. And then you start to see the chances for La Nina emerging as we go through August, September, October, November, December, January, and February here. So pretty good chances we are going to be dealing with La Nina. And if you're along the west coast of North America, you're probably already starting to draw a picture in your mind of what we can expect here. Definitely a little bit cooler here across Pacific Northwest, usually a little bit windier, a little bit wetter, and better chances for snowfall in both the mountains and the lower elevations. So the National Weather Service, or the Climate Prediction Center, poses this question: do strong El Ninos lead to strong La Ninas? Yes, no, it's complicated. You can see previous moderate or strong El Ninos here, and we usually head somewhere into this negative territory, at least neutral conditions now, but it doesn't always mean that we're headed towards a strong La Nina here, and we're going to take a look at that in a little bit more detail here coming up in a moment. Now, if we take a look again at Nino 1.2, showing you that upwelling along the immediate coastline there, you can 3.4, you can see 3.4 here, and you can see we peaked out right around 2.1 there in late November. As we went through December, you can see the slow, steady decline as we head off towards May, shown up here. And this was last issued again just yesterday on June 24th. So the weekly sea surface temperature anomalies here across the tropical Pacific, if we let this animation play, you can see that upwelling on the coastline here and as it snakes across. And that's why we're dropping these temperatures here across the key monitoring region, otherwise known as Nino 3.4. If we take a look at what is going on below the water here, I've been showing this off and on here as I do these monthly updates, but you can clearly see we have a lot of cold water here at depth, and you can see this is between 50 and 150 meters here, and you can see depth in feet to the right there as well. And again, this upwells and starts to push out across Pacific Ocean, and again, this has implications all the way across the globe, which we're going to be looking at here in a minute. Model predictions of ENSO from June 2024. You can see we're going down towards La Nina here, but this is not a slam dunk that we're going to be in La Nina. There is a chance we could still get hung up in neutral conditions, although some models do show us getting in. Actually, most of them do show us getting into at least a week here, and some of them potentially even towards a moderate La Nina coming up. We're probably not looking at a strong La Nina. As you can see, the CFS here, just a few of the ensembles do clip the strong category here, but you can see overall the ensemble mean is right there, moves into a weak La Nina as we go through the summer months here, and then hangs out somewhere around moderate. You can also see as we go through August, September, October, November, December, January, and February, that cold tongue emerging across the central Pacific Ocean. So historical Nino 3.4 sea surface temperature anomaly, you can kind of see how this cycles through. We get El Nino, then we go through these La Nina conditions back and forth. So you can kind of try to pick up a pattern here. And we just went through this La Nina here, and now we are coming out and probably headed towards La Nina as we go into 2024, 2025. So winter La Nina patterns generally look like this. You can see the variable polar jet stream here. The blocking high pressure is a classic signature of La Nina out here, and it brings us this more variable jet stream that brings wetter and usually cooler conditions here to some of the west coast, including maybe some of Northern California there. During El Nino, it's a bit different. As you can see, we've generally got warmer and wetter for south areas. And as we found out this year, this doesn't always, this isn't a slam dunk. Just because you have these conditions, you're just kind of loading the dice. Now, if we take a look at the Canadian model here on the left, and the Canadian also, we're just comparing it versus its seasonal prediction here for June, July, August, and this is a July, August, September. But you can clearly see it does predict this cold tongue coming across. These are clearly La Nina conditions. And if we move on in through September and October, you can see this continue on into the fall months. Here we go, November, December as well, and there's January and February. So clearly showing these La Nina conditions. And this goes all the way out to March and April here as well. But if we look at the European, I've got animations going on here, and you can see the European has this signal, probably a weak La Nina here, but you notice it's not that cold here, at least compared to what the CFS is showing. And the CFS does tail off here pretty quickly as we go through the end of the winter here and on through the early portion of spring here. So we have still a lot to watch coming up here, but we're likely looking at least a weak La Nina. So the European also does this. This is the anomaly plume. So this is all the way back to September 2022. The red lines here are the ensembles for the European forecast of what temperatures we're going to be dealing with for Nino 3.4. So the blue line is what happened. So you can see pretty good forecast here from September 2022. This is the forecast from October 2022. And again, a pretty good forecast here. This is the actual performance of that Nino 3.4 region versus what the ensembles were saying. And if we go on through November, the temperature is a little bit on the high side here, but still within the ensemble spread. And you can see December also on the right. There goes January 2023. There's February, pretty good. March, April, you guys get the picture here. But as we start to go through May, you notice that the actual what actually occurred there across Nino 3.4 was actually a little bit on the low side here, but still within the ensemble spread. And then we go to June 2023, and again in August. You can kind of see how it was on the low side here. We were supposed to peak out with a little bit stronger El Nino here, but we were on the low side of those ensemble runs. And if we go on into September, something similar there on the low side. October, a little bit on the low side as well. November, something similar there also. So we're now diving down. You can see the blue lines clearly bringing us down towards the neutral conditions by the time we got towards May. This is the December forecast here as well. Here we go, January. There's February. There's March. Here's April. May just a month ago here. And yeah, so you can see what the ensemble spread was showing as May. But look at for June. We've kind of backed off a little bit on just how chilly the waters are going to get across the equatorial Pacific there. Now, we talked about this a little bit here coming up here. By the time we get towards September 2024, just about 2/3 chance, 65% chance we're going to be in La Nina conditions. And then it's an 85% chance of that persisting on into the winter as we go through November and on and through November and January. So this is since 2012 here. And if we look, we have El Nino that lasted about 12 months, this last one. And you can see our triple dip La Nina here that we had between 2020, 2021, and 2022 that came to an end in 2023 here. So you can kind of see that cycle here for the last 12 years or so. Now, again, this is the latest weekly value for Nino 3.4. I just like to give these visual diagrams here, and you can kind of see that colder water snaking across the Pacific Ocean here. This was issued on June 23rd, and the upwelling brought the demise of El Nino here, and I believe this is an animation. It may be. There it goes. Yeah, you can kind of see it here, and you can see the timeline as we run through the month of June. So under normal conditions here, we have what are known as trade winds here near the equatorial Pacific Ocean here. And if you've been out to the Hawaiian Islands, you hear trade winds talked about in the forecast there as well. But this is kind of typical. You do heat up some of the Western Pacific more than you do the Eastern. And you've got these currents that work across Pacific Ocean and kind of the opposite there across the Southern Pacific Ocean. So when you get into La Nina conditions, again, this blocking high is the characteristic. The defining characteristic of La Nina that brings that variable jet stream, cooler out of the northwest here, and usually wetter here across the Pacific Northwest as well. Drier and warmer weather here across the southwest, kind of a characteristic of La Nina as well. Increased trade winds, and you build up that heat across the western Pacific here. Actually, let me back that up here. Oh, let's go back to that one. And you can see that we're building up that heat here. And with that heat in the very cold Siberian portion of Asia here, you have a really strong gradient. So you have these power-packed jet streams that roll off of the continent of Asia here. And then eventually you get downstream and you get that ridging there, these strong storms out here across some of the western Pacific. You get that blocking high pressure, and then you allow the variable jet stream and that northwest flow to come across the Pacific Northwest. And again, kind of highlighting this, the wet and cool pattern here across the Pacific Northwest as well. So what exactly is going on there? So you got neutral conditions, and you can see, again, the Pacific Walker circulation generally enhanced here across the Western Pacific. Again, warmer water, you usually get a bit more convection out there. As we go from La Nina, you enhance this Walker circulation across the Western Pacific. And again, that really amplifies that blocking high across the Pacific Ocean. El Nino, it's different. You bring that convection out over the warmer water that bunches up. Adds up there across the central Pacific Ocean. The convection develops there instead. So how do we know if the Walker circulation is starting to show El Nino or La Nina conditions, I should say? One way is by looking at the Southern Oscillation Index here, because you can see we've been doing pressure observations there at Darwin and Tahiti here. So we can compare these conditions there, and then you can see if you have higher pressure for Darwin and lower pressure for Tahiti, where the convection would be enhanced, that's El Nino. If you reverse that and you got the lower pressure here and you're enhancing that convection out across the Western Pacific, the pressure is going to be lower here for Darwin, and Tahiti, it's going to be higher. That's La Nina conditions. And you can see this goes all the way back to 1951 here, and you can see when it is pressure higher in Tahiti positive, we have these La Nina conditions. You can see our last triple dip La Nina here, and the one we had back in the late 90s and into the early 2000s. You can also see these super El Ninos here, and we had the higher pressure in Darwin, which is in this negative territory, and the most recent El Nino, not too impressive there, and we're kind of right around, I think it's negative 0.2 it is for April 2024, so that's right around neutral conditions, which makes sense right now. And there's other ways you can look at this as well. You can see when we did have the ongoing El Nino from January on in through March, you can see how we had the increased, the blue shading there, wetter than average conditions across the equatorial Pacific. This is 180 degrees near the date line. 120 is getting way out towards the maritime continent. So as we look off in towards March, April, and then May, and eventually June, you can kind of see how we've had the outgoing long wave radiation has been increased here, which means less convection across the date line. And that's starting to pick up here across the Western Pacific, which also points to La Nina conditions eventually developing. And this is something cool here as well. This goes to the end of December. You can see the warmer water there, and this is kind of showing you off the coast of South America here, and then across the Nino 3.4 region. Let me go backwards here again. And you can see the developing colder water here as we scroll through the timeline. We go from December to January, February, March, April, May, and June here. And you can clearly see the colder water starting to emerge off the coast of South America. Definite signal there for the developing La Nina. So Rossby waves, these are what drives the storms across the northern hemisphere here as we get on into the fall and the winter months. They're called mid-latitude cyclones because that's where the strongest gradient sets up here. And I'd like to show this diagram from time to time, especially during the fall, winter, and early spring months here. We can really see the stronger pressure gradient. And El Nino and La Nina and the way the warmest air there moves across the teleconnections from the tropics really affect how these Rossby waves set up. So again, I talked about the gradient between the polar and the equatorial regions being the mid-latitude cyclones. And the stronger the mid-latitude cyclone, the stronger the gradient, the stronger the winds, the stronger the storm. So again, a tropical teleconnection here. Once you get that deep convection out over the central Pacific Ocean, you tend to have a stronger jet stream that feeds into the west coast. That's why a lot of people in California sometimes kind of fear El Ninos, because it gets a little bit crazy there. You can get some pretty intense flooding, and then you get to warmer conditions here across the Pacific Northwest. And again, La Nina is different, characterized by that blocking high pressure that I've told you about several times before in this video itself. But if we take a look here, now we're looking off into the extended forecast. This is on June 20th here. This is recently updated, and you can see October, November, December. Look at this signal for the Pacific Northwest. Equal chances as far as temperature, above average across the Southwest, above average once you get on in towards November and December. However, Now, if we look on into December, look at that signal, classic La Nina signal here for the Pacific Northwest for December, above average precipitation as well. And here we go for January, below, February, below. And it goes on for March and on in through April, I believe, as well, below average. Of course, you take that with a grain of salt, but there are pointing at the classic La Nina signal coming up. So this is something I like to show. This is the snowfall from 1981 to 2023 at SeaTac. And you can kind of see the El Nino years generally on the lower side. Every single one, 2, 3, 4, 5, 6 of the years. There's only 6 years with no snowfall. They were all El Nino years. And it doesn't take a strong La Nina to bring impressive snowfall totals. The December 2008, remember that big snowstorm or combination of big snowstorms, snowstorm after snowstorm in December of 2008, that was a weak La Nina. And look at that, 23.3 inches of snowfall, the greatest in the last 40 years or so for SeaTac easily. And neutral years don't do that bad as well. And you can see every once in a while, even during a weak El Nino, remember February 2019, that was a weak El Nino conditions as well. And this last El Nino, we had just a scant 0.3 inches of snowfall at SeaTac. And you can kind of see that signal here for High Central Cascades, Washington State snowfall per season. And you can see the biggest years are La Nina years. And you can see some El Ninos occasionally will have more snowfall than some of the La Ninas, but you can clearly see there is a signal based on La Nina versus El Nino. And this is something else as well. For example, if we look at Paradise, this is an interesting signal because strong La Ninas, this is an incredible amount of snowfall. 911 inches from 1950 to 2004 for Paradise during strong La Nina. So if you really love the snow there across some of the Cascades, you really want that strong La Nina to show up. Right now, the models aren't showing that, but you can see there is a signal there, and you get to the lowest point with the strong El Nino. You can also see Stampede Pass, the strong El Nino versus the strong La Nina, etc. Snoqualmie Pass, there's a definite signal there as well. Stevens Pass, even for Whistler and places like that, Whistler Mountain also. So it can flip around a little bit here across some portions of California. Some El Ninos can still bring decent amounts, but it's usually at higher elevations. But yeah, I'm going to keep doing these as we go. So the next one will be out probably mid-July again here, somewhere around July 15th to July 25th. And we'll go on and we'll do the exact same thing, and we'll break it all down again, and we'll take a look at what is upcoming. But right now we are definitely headed towards at least neutral conditions and most likely La Nina conditions. And that is usually a good thing for winter weather lovers here across the Pacific Northwest, especially. And it's a good news for snowfall across the Cascades and whatnot as well. So anyway, yeah, so what is next? We got some thunderstorms moving in tomorrow, so I may actually go out and try to chase a little bit of that and try to capture some lightning here across the Pacific Northwest. Have not decided if I'm going to go out for that just yet, but either way, I'm going to do a briefing tomorrow, either in the morning or when I get home after that chase. Otherwise, I hope you guys are liking this channel. Click like and subscribe. We will do this all again next month, and of course, I'll do my daily briefing, so stick around for that. Click like and subscribe, and I will talk to you guys tomorrow at some point.